number, that is magnetic quantum number. Again, if I have to remind you of this example, what is the bottom part? That is the orbitals. That is your third quantum number. What is orbitals? It is the room where you find the electron. For example, if you take yourself, okay, let us assume you are the electron now. So this room in which you stay will become the orbitals or the magnetic quantum number. Now, where is your room? Which state it is? That is your azimuthal quantum number. Your state is in which country? That is your principal quantum number. So this is how you can relate it. So, orientation of atomic orbitals in space. This is what magnetic quantum number means. This is represented as M. Okay. Orbitals. Now there are different orbitals. Okay. Now the subshells. In the previous one, we studied about subshell. Now when these subshells are subjected to external magnetic field, what happens? They start orienting themselves. Okay. Now these oriented objects are called as orbitals. See, they are called as orbitals. They are represented as M. Suppose you know the L value and you have to calculate the magnetic quantum number. How you are going to do? You are using the formula minus L 0 plus L. Okay. By using this formula, you can calculate the number of orbitals. Now, how you will find out how many orbitals are present? That you can use. That you can find by using this formula, that is 2L plus 1. L is nothing but your azimuthal number. So 2 into L plus 1 will give you how many orbitals are present in that subshell. Now what is L? L is nothing but subshell. What are you finding here? We are finding orbitals, that is represented as M. How to find orbitals? By using this formula minus L 0 plus L. How many are present orbitals? That is, you will be finding through this one. So moving ahead, we have the values. Okay. Now you have L value. 0 is nothing but S subshell. Okay. What is the M value? L. How did you find out? From the formula 2L plus 1. That will give you 1. I have L value as 1. Name is P subshell. How many values I will get? 3 values. 2, 5 M values I will get. 3 is for S subshell. I will get 7 values. So this, let me explain. Quantum number, that is magnetic quantum number. It is represented as M or ML. Okay. These are nothing but orbitals. Now shells, under shells we have subshells. Subshells are further divided into orbitals. Now this is where you find your electrons. These are the rooms. Orbitals are nothing but room where you find the orbitals. Now here, for every subshell, how do you calculate ML value? We are taking the subshell. Now for every subshell, which is nothing but L, which is denoted as L, the ML values are calculated as minus L, comma 0, comma plus L. Okay. For example, now I have my L value as 0. What is 0? That is nothing but S subshell. How will I calculate my orbitals or ML value? It is nothing but minus L 0 plus L. Since it is 0, my ML value is 0 itself. Okay. Moving ahead, I will take L is equal to 1. What is L is equal to 1? It is P subshell. Now again, let me take my ML values or let me calculate the orbitals. It is 1, so I will write it as minus 1, 0 plus 1. Minus 1, 0 plus 1. This is my orbital. How many I have? I have 3. 1, 2, 3. I have 3. In the previous subshells, how many rooms were there? There is only one room. The value is 0. But how many rooms? 1. It is a value, right? Even if it is 0, it is one value. So it is one room or one orbital. Moving ahead to D subshell, L is equal to 2. Write in this format. I will get it as minus 2, comma minus 1, comma 0, plus 1 plus 2. So how many are there? 1, 2, 3, 4, 5. How many rooms? 5 rooms. So D subshell has 5 orbitals. Okay, it has 5 orbitals. Next, L is equal to 3. In the same format, if you write, you will get it as minus 3, comma minus 2, comma minus 1, 0, plus 1, plus 2, plus 3. So how many orbitals are there? There are 7 orbitals. So this is how you calculate the orbitals. Now moving ahead, since every orbital has a name, okay. Now I have P subshell. Since it is only one room, it is called as S orbital. Okay, it is only one room. That's why it's called S orbital. Now P subshell, there are 3 rooms or 3 orbitals. They are called as Px, Py, Pz. D subshell, there are 5 orbitals. These have 5 different names. That is dxy, dyz, dxz, dx square minus y square, and dz square. So the pictures and shape of these orbitals, I will show it on the screen. So now I think you're familiar with the shells, subshells, and orbitals. Now it's time to see the name of the orbitals. So if I have S subshell and M value as 1, it is S orbital. P subshell and these values, I will have 3 orbitals. Okay. Always for P subshell, there are 3 orbitals present: Px, Py, Pz. D subshell, dxy, dyz, dxz, x square minus y square, and z square. These you need not by heart, but you have to know this. You have to know S orbital, Px, Py, Pz, and these 5 d orbitals. Okay. Why do you get different? As I told you, it is the orientation. When a subshell is exposed to an external magnetic field, it will orient itself in different directions. Okay. So here you will get 3, and here in D subshell you will get 5. So moving ahead, let us see the shape of the orbitals. Okay, these are the shapes. S orbital is always spherical in shape. P orbital is dumbbell shaped. Okay, this is one orientation. Can you see it is oriented along the Z axis? Here you have Y and X. If this P orbital is oriented along the Y axis, then it is Py. This is Pz. This is Px. Now D orbital, there are 5 d orbitals, and these are the shades of it: dyz, xz, x square minus y square, dxy, dz square. You just have to know the names, not the shapes at this level. Okay, and this is the shape of F orbital. So moving ahead, we have the last quantum number, that is the spin quantum number. Now what is this? It is nothing but it represents the direction of spin. Here you can see these are nothing but electrons. The one which is pointing upwards and the other which is pointing downwards. This is the representation of electron. It does not look like this, but it is represented. Can you see it is present inside a box? That box is nothing but orbital. Okay. Inside the orbital, you will find your electron. Now, what is spin? Spin is nothing but this electron is rotating on its own axis. There are 2 axes. One is clockwise, other one is anti-clockwise. So the value of this electron is plus half. The value of the other one is minus half. So there are 2 possible values. If it is pointing upwards, it is plus half. If it is pointing downwards, it is minus half. So this is the spin quantum number. Now this is the final chart. This I will write it again and show it. So this is the final chart which explains the whole concept of quantum numbers. So here I have in my first column it is principal quantum number. Next I have azimuthal quantum number, magnetic quantum number, spin quantum number. Then there are number of orbitals, the name of the orbital, number of electrons and total electrons. Okay. So first let us see from the K shell. Now K shell n is 1, so I will get the name as K shell. L is nothing but azimuthal quantum number. How did I calculate it? It was 0 to n minus 1. I got it as 0. ML, magnetic quantum number, that is orbitals. How did I calculate it? I calculated it as minus L, comma 0, comma plus L. MS, this is spin of electron. Okay, it is always plus half and minus half. Number of orbitals. How did I get this? That is S orbital. It is 1. Number of orbital is 1. Name of the orbital 1s. Number of electrons. Now here I have 2 electrons. How many rooms I have? Only 1. So 1 into 2, 2 electrons. So total electrons are 2 electrons in my K shell. Next, moving on to L shell. I have my L values as 0 and 1. Okay. Now ML value. ML is nothing but orbital. This is subshell. This is my S subshell. This is P subshell. Now in S subshell, I have only one room or one orbital. That is S orbital. This is P subshell. P subshell has 3 rooms. Minus 1, 0, plus 1. That is P orbital. Px, Py, Pz. Then ms values, electrons. These are 2 electrons. Now here, this is one room. S orbital is one room. In one room, there are 2 electrons. Here there are 3 rooms. In each room, you have 2 electrons. Okay. So number of orbitals. How many rooms? 1 room. Here 3 rooms. Names of the orbitals. That is 2s and 2p. 2s, 2p. Number of electrons. 1 room is there, 2 electrons. 1 into 2, that is 2 electrons. 3 rooms are there and 2 electrons. 3 2s are 6. Total it is 8. Okay. Next is M shell. In M shell, I have 3 subshells. S, P, D. Now orbital. This is S orbital. This is P orbital. This is D orbital. S orbital has only 1 room. P orbital has 3 rooms. D orbital has 5 rooms. In each of these rooms, you have electrons. Okay. So 2 electrons in 1 room. So number of electrons are 1 into 2 will give me 2. 3 into 2 electrons is 6. Means 2 electrons are present in each room. How many rooms are there? 3 rooms. So 3 into 2 will give 6. 5 into 2, 10. Now here, name of the orbitals. 3s, 3p, 3d. Now total number of electrons. 10 plus 6, 16 plus 2, 18. So 18 electrons are there in M shell. N shell, I have S, subshell, P, D, F. These are the orbitals and these are the electrons. In S subshell, I have only 1 orbital. In P orbital, there are 3 rooms. D orbital, 5 rooms. F orbital, 7 rooms. Now, electrons present in this orbital, that is 1 into 2. I'll get 2 electrons. 3 into 2, 6. 5 into 2, 10. 7 into 2, 14. These are the names of orbitals. Total electrons. That is 10 plus 6, 16 plus 2, 18 plus 14, 32. So this is the chart of quantum numbers. If you know this chart, you can easily solve any given electronic configuration. Thank you for watching our video and please don't forget to like and subscribe to our channel. Thank you.